Hello, welcome to this lecture video. So our concern is to answer this problem. Is there a significant correlation between the age of the employees and their initial BMI classification? So let us review what is the data all about. So this is our data. So we have the BMI before and BMI after with the following values. So 1 means underweight, 2 normal weight, 3 overweight, 4 pre-obese, and 5 is obese type 1. So our data is not a numerical data. It is a categorical data, particularly an ordinal data. Of course, the initial that we are referring here is the BMI before. Now let us move to our to the age. So we cannot find for values for age simply because the age that was used in the data is the actual age. So we have this actual age. Actual age is the scale or it is a ratio. So now, if we will be getting our purpose is to get the correlation. So our focus is to get the correlation between the BMI before or the initial BMI and of course the age. So as mentioned, BMI before is an ordinal data. Age is ratio ages ratio. Now, of course, the correlation test that we might think about to solve this problem is the Pearson R. But Pearson R is a parametric test, which means that we cannot use it when our data is not at least interval. So which means in this problem, Pearson R cannot be used because our BMI before or the initial classification of BMI is not at least interval. Therefore, we are going to use the non-parametric test. And the non-parametric test that we will be using is called Spearman rule. So just like with our Pearson R, we are also going to determine whether there is a negative or positive correlation. Negative, which means that the correlation is inverse, while if it is positive, it means that the correlation is direct. And if it is an inverse, it means that as x increases, y decreases, or vice versa. It is also possible that as x decreases, y decreases, as long as it is inverse. While if it is direct, it also means that as x increases, y increases. Or again, it can also be x decreases, y also decreases because there is a direct correlation. Now, if the correlation is very near to zero, it means that there is no correlation. So just also to recall what is the definition of this value or the meaning of the values obtained. The perfect correlation is -1 and the perfect positive correlation is also +1. So these are perfect and also perfect. So if you will be asking me if which is higher, is it the -1 or it's the +1? So obviously the strength of a -1 is the same as the strength of a +1, except that the correlation is not the same. So if it's negative, it just indicates what type of correlation. So it is, of course, an inverse correlation. Well, if it is positive, it means that there is a positive correlation. So we can divide this by considering zero point 0.5, a negative zero point 0.5, and a positive zero point 0.5. So we can say that between 1 to negative is considered weak, and from 0.5 until before negative 1 is strong. So just the same, even if our result is positive, we have the same interpretation. So negative, or I mean positive, weak, and positive strong correlation. So for some materials, you can also see that they still divide this. Like for example, for the weak, if we will be dividing this into 0.25, we can also say that this is considered very weak, weak, strong, and very strong. So similarly, on the other side, positive side, if we are also going to divide it again into two, the 0.25 in between 0 to 0.25 is considered very weak. From 0.25 to before point 0.5 is considered weak, strong, and very strong until perfect. So it's up to you what you prefer, of course, as long as if it's very near to zero, you can state that it is weak, and if it's very near to one, it's also a strong correlation. Okay. So let us now answer our problem. What is the correlation, or rather, is there a significant correlation between our BMI, initial BMI, and the age? So what will we do? Click Analyze, Correlate, Bivariate. Analyze, correlate, bivariate. And let's transfer BMI and initial BMI and the age. So the default here is Pearson. So let's change that into Spearman and remove the check mark in our person. And then click OK. So this is now the result. Let's snipe this. Copy and let's paste it in here. Okay. So what is again, the meaning of this table? So as we can see here, there is a double asterisk indicating that there is a significant correlation at 0.01 level. So this is the double asterisk that I am referring to. So it is a positive. Of course, BMI and age is just the same with age and BMI. So later, if you will be presenting this, it's okay to delete some parts. Like, for example, you can delete the first column and just retain the BMI and age. And you can also delete the second row for this row. If we will be interpreting this, it means that the correlation is positive. So which means there is a direct correlation. It is also telling us that as X increases, Y also increases, or vice versa. And we can also see that the value is 0.6. So it is above 0.05, or it is 0.05 and above. So it means that there is a strong correlation. So when we say that we have a passive, as x increases, y decreases, so it means that those subjects with high initial classification of BMI are those with also older age. So that is what we mean by as x increases, y also increases. And the correlation is strong, and this is supported with our p-value, which is significant. So the p-value is indicating us that there is a significant correlation between the BMI and the age. So again, we use non-parametric test because the BMI is not numerical, it is ordinal. So we can use non-parametric test. We can use Pearson R if the problem is correlation, and if one of our two data or two variables rather is not numerical anymore, we can no longer use Pearson R. So this ends this video. Thank you for watching.